Hey there learners, my name is Karan. I'm a software developer at Citrix and I'm currently working on Python, Java and React. I've been mentoring at Newton School for over 4 months now and I have experience in hosting multiple programming workshops. Newton School is a platform which prepares you for a career in tech. It has specially designed courses for freshers, working professionals and also for women with no prior technical background. Newton School first trains you for 6 months and helps you become an amazing full stack developer. It also has a network of more than 300 great companies who hire directly from Newton School. So once the training is complete, Newton School also ensures that its students are placed with some of the best companies in the country. And the best part about this is Newton School has a pay only after placement program under which you don't have to pay Newton School anything until and unless you are placed with a minimum CTC of rupees 5 lakhs. Launchpad is an initiative taken by Newton School for people who want to start coding from scratch and learn the basics of different programming languages absolutely free of cost. This video would also be available in the Launchpad section of Newton School. There you can practice several quizzes and assignments related to this course. You simply have to sign up on the Newton School portal for free to get started. So let's talk about the course now, Python for beginners. Python is a programming language that is easy to learn, which is why many amateur coders choose it as their first language. Because it was built as a general purpose language, it is not limited to one type of development. You can use it for anything ranging from analyzing data to creating games, building websites, etc. Hence, if you are a beginner and wanting to get into the field of software development, this is the perfect opportunity. Follow this series, sign up on Newton School, and start using the Launchpad to hone your coding skills. Whether you are new to programming or simply interested in learning a new language, this course is perfect for you to get started. So let's talk about history of Python. Python is a high-level interpreted scripting language developed in the late 1980s. Developed by Guido van Rossum at the National Research Institute for Mathematics and Computer Science in Netherlands. Python is still maintained by a core development team at the institute. Guido is still in charge, declared BDFL, Benevolent Dictator for Life, by the Python community. The name Python, by the way, derives not from the snake, but from the British comedy troupe Monty Python's Flying Circus, of which Guido is a big fan. So why choose Python? Python is popular. Python has been growing in popularity over the last few years. The 2018 Stack Overflow Developer Survey ranked Python as the 7th most popular and the #1 most wanted technology of the year. World-class software development companies around the globe use Python every single day. Due to the popularity and widespread use of Python as a programming language, Python developers are sought after and paid well. Python is interpreted. Many languages are compiled, meaning the source code you create needs to be translated into machine code, the language of your computer's processor before it can be run. Programs written in an interpreted language are passed straight to an interpreter that runs them directly. This makes for a quicker development cycle because you just type in your code and run it without intermediate compilation step. Python is free. The Python interpreter is developed under an OSI approved open source license, making it free to install, use and distribute even for commercial purpose. Python is portable. Because Python code is interpreted and not compiled into native machine instructions, code written for one platform will work on any other platform that has the Python interpreter installed. Python is simple. As programming languages go, Python is relatively uncluttered and the developers have deliberately kept it that way. A rough estimate of complexity of a language can be gleaned from the number of keywords or reserved words in the language. These are words that are reserved for special meaning by the compiler or interpreter because they designate specific built-in functionality of the language. Python 3 has 33 keywords and Python 2 has 31. By contrast, C++ has 62, Java has 53 and Visual Basic has more than 120. But it's not that simple. For all syntactical simplicity, Python supports most constructs that would be expected in a very high level language, including complex dynamic data types, structured and functional programming, and object-oriented programming. Additionally, a very extensive library of classes and functions is available that provides capability well beyond what is built into the language, such as database manipulation or GUI programming. Python accomplishes what many programming languages don't. The language itself is simply designed, but it is very versatile in terms of what you can accomplish with it. So, in conclusion, Python is a great option whether you are a beginner programmer looking to learn the basics, an experienced programmer designing a large application, or anywhere in between. The basics of Python are easily grasped, and yet its capabilities are vast. Let's start by writing a simple Python program to print hello world. This can be done in Python by using the print statement. I'll be using the Newton Schools IDE. This can be accessed by signing up on the portal, and it's absolutely free. Once signed up, create a playground with an appropriate title and description. Once the playground is created, go ahead and select Python 3.8 in the drop down over here. We'll be using Python 3.8 for the duration of this course as it is the latest version of Python. The code can be written in the window here. Now once the code is complete, go ahead and hit run, and the output will be printed in the window over here. So there you go everyone, we have written our first Python program to print hello world. Let's move on to basic data types in Python, the first one being integers. Integers are basically whole numbers. In Python, any length is allowed up to the memory limit of the computer, and by default integers are decimals of base 10. Let's look at a few examples on how to set variables to integers. In Python, variables can be set to integers by a simple assignment operation, and these variables can be used to perform arithmetic operations. As you can see, we are printing a plus b and a minus b, which is 12 and 8 respectively. We can also use the type function to ascertain the type of the variable, and if I run this code, it outputs that integer a, variable a is of type integer. The next basic data type is the floating point numbers. Floating point numbers are any number with a decimal point. In Python, division results in a floating point number. Now, the simplest way to define a floating point number in Python is to assign a variable to a number with a decimal point and a number after it. So both a and b are of class float. We can verify this by checking using the type function, and as you can see, the type function returns float class for variable a. Now I mentioned that division in Python returns a floating point answer. So let's try that out over here. So we have c is equal to 5 and d is equal to 2. If we do the division operation on these two variables, the output is a floating point number. Now in order to do integer division, which returns an integer output, we can use the following operator in Python, and as you can see, the output is of type integer. We can verify the type of output by using the type function. And rightly so, the division, normal division, returns type float and the integer division returns type int. The next data type is complex numbers. They are in the form of ax plus bj, where j is the square root of -1. They consist of a real part and an imaginary part. In Python, you can define a complex number by setting a variable with a real part and an imaginary part. We can define another variable similarly. Now when we go ahead and check the type of one of these variables, we can see that it is as expected, which is class complex. Now these variables can be used to perform any of the mathematical operation that you expect to perform on complex numbers like addition, multiplication, subtraction and division. As you can see, we have gotten complex number outputs for all of these operations. Next we have strings. Strings are basically sequence of characters. In Python, strings are surrounded by either single quotation marks or double quotation marks. You can display a string literal with the print function. So coming to some examples, a string can simply be defined using double quotation marks, or it can also be defined using single quotation marks, and it can be printed using the print function. Now when we go ahead and check the type of this variable, it gives the class str, which is short for string. Now the plus operator in Python can be used to perform string concatenation. As you can see, a plus b will concatenate the two strings ab. In Python, we can also use triple quotation marks to define double line, multi-line strings. For example, so I have used triple quotation marks over here to define a string C, which is a multi-line string. Now when I print this string, it will follow the multi-line structure that I have given it as under the quotation marks. Now coming to the last basic data type in Python, which is Booleans. Booleans represent one of the two values, true or false. In programming, you often need to know if an expression is true or false. You can evaluate any expression in Python and get one of the two answers, true or false. When you compare two values, the expression is evaluated in Python and returns the Boolean answer. Now, a Boolean is easy to define like the other variables. Now when we go ahead and check the type of this variable, it returns class bool, which is as expected. Now whenever we perform comparison operation in Python, it returns a bool value. For example, 6 greater than 5 is true. Hence when we print C, Python outputs true. Another example can be that 10 equal to 0 is false. So when we print D, the output is false. The bool function in Python can be used to evaluate variables. For example, now universally 0 is equivalent to a false. Hence the bool function returns false. However, for 1 or any other integer value, it returns true. Now most values in Python or in any other language evaluate to true. For example, a non-empty string or a non-empty list or a non-zero number will always evaluate to true. However, some values can also be false. Mostly the values which bool evaluates are false are empty or values which have 0. For example, 0 will be evaluated as false, an empty list will be evaluated as false, and even a empty string will be evaluated as false. So as expected, we see that non-empty string and non-zero numbers are evaluated as true, and empty string, empty list or a 0 is evaluated as false. This was it from the first video of the series Python for Beginners. Thanks for watching. Please subscribe as more videos are coming up in the series. Lastly, feel free to leave any doubts in the comment section. Bye for now.